Okay, good afternoon. Actually, I'm deeply honored to be invited here, and you give me a very good reason to come here to visit your beautiful country at the very right time because of the agreement regarding the harbor just signed. And China and Sri Lanka has a very long friendship, and many students are there in my school. So that's why I come here. I'm quite happy to be here to give you some brief introduction about our research in my team. Actually, this presentation comes from two of my MSc students. One of them has just graduated from my university, another is still here in my team. And the basic idea is about how to use AI, artificial intelligence technology for our geographical information visualization. So, as you know, in the domains like computer game, like social activities, and life and education, all these domains, we have computer. And basically, mobile computer or mobile phone, that's the main information source for our daily life and also our work, our scientific research procedure. And the trend is that this information visualization from the computer science is mainly indoor, because indoor is this everyday space. So most computer science make their concerns with this everyday space. But for our geography and survey and mapping, our space is a geographic space, so it's an outdoor space. And from indoor to outdoor we use computer technology in our geographic space. And now we have this wearable computing technology. That means the computer can be wear on our body, or we can bring this computer with us. Yeah, this watch, these glasses, and even head-mounted display. Yeah, all these are wearable, so it is along with our body. And then now we have this location-based service and also augmented reality. So in the US and China, the very hot topic about visualization is this AR, VR system. So it's virtual reality and augmented reality, because this kind of technology can help us to see a different world. So our idea is to use this technology to enhance the visualization of geographic spaces. And of course, we need more timely information and more accurate information. So now we have this technology of augmented reality that use virtual information to augment the real information. So here we have some technology like image registration. Image registration means you must put this virtual information onto the real world that we see. Yeah? Because many virtual information in computer cannot be seen by our eye, but by this augmented reality technology, we can visualize this virtual information and superimpose them on the real world. That's the idea of augmented reality. So the technology has developed from this feature point-based identification. That means to find something from a picture. So to find someone or some cat or dog from an image is a very classic problem in computer image processing, for example. So the traditional approach is what we call the feature point based. Yeah. But this kind of approach has some disadvantages. For example, it is complicated computing and error-prone, and timeliness cannot be guaranteed, and also it needs human involvement. Yeah. But now we have this deep learning. So deep learning-based approach is quite a new approach because deep learning has just developed for years, and it is now used mainly in Google or this big IT company. They use this kind of technology to process this online information, and mainly for image data. So for this approach, usually we need GPU, and we need high accuracy, we need faster calculating, and we need what we call end-to-end black box computing. Yeah. So we see that deep learning could be used in GIS in our geographical space to help us to solve some problem which cannot be solved well before. So deep learning has its development and its application. So from aspect of development is this CNN, this convolutional neural network was firstly used in ImageNet competition from 2012, and this, should I continue?
Yeah.
Okay. And this kind of approach has developed very rapidly. So the error reduced by 10% to 60% compared to the feature-based approach. And now it's continue to reduce until to 3%. So that means this kind of approach can help us to reduce the error. And now the approach has been used in image classification, object identification, gesture evaluation, image segmentation, or face recognition. So now this deep learning has been used widely in the field of image processing. Yeah. Now the mainstream models has a lot. Yeah, this CNN has a lot of variety. Yeah. So it has advantages. It is highly reliable and timeliness, end-to-end, and the training ones used in anywhere. Okay. Okay, so that's all about deep learning. And we see our roadmap. Yeah. So first of all, we need a visual identification model because we need some kind of a model which is installed on mobile phone, yeah, so that we can use on mobile phone. So then we find CNN is called simplified CNN. Yeah. It is integrated with this two-dimensional attribute and the three-dimensional geometry and also this human-computer interaction. Yeah. So from here you can see that we have this heart rate tracking and the registration, yeah, and integrated with LBS and with augmented information, and then with a three-dimensional image registration. Yeah. So so first, the sensor-based non-visual context perception. Yeah, that means the information censored by mobile phone itself, for example, but it is non-visual. And then we use GIS provided a function like surrounding retrieval, like set minute to scope of computing, and also we use attribute association. And then we need technology for mapping from 3D object to 2D screen coordinate system. Yeah, and the reverse approach. So our methodology and the result. So this is our approach to solve the problem. A, B, C, D, E. So A is a model design. First of all, we need to find a model. Yeah, and B is to model train the model. Yeah, because deep learning is based on neural network. So the basic characteristics of neural network is training. So we must train the model, and then we develop a prototype system design, and then implement it, and then we can execute and test. Yeah. So first of all, the model design. First of all, we need to choose a model. Yeah. So based on Google research, testing our mainstream CNN model, we have this SSD. It is a abbreviation of a single shot multi-box detector. So it's a CNN model called SSD. Has better performance on detection and identification of large object in the image. Yeah. And then we simplify this SSD model by model structure to facilitate using a mobile phone with a reasonable performance. So our main task is to transplant this SSD into simplified SSD, so that which can be used in mobile environment. Yeah. So there is a lot of technology detail about how to describe this kind of SSD model. Yeah. So it has. So you can see here what kind of simplification has to be done here. Basically, we reduce the layer to be computing, and we reduce the output side, and okay, and some others. Yeah. And then we can go to model training. Our training based on this sample data. So here we mainly treat three categories of objects. Actually, the data, the building, and the building. Yeah. What we call the 3S state, which is at the center of the square of my campus, and the higher building is a teaching and the research building right opposite of my building. And actually, the bottom, the building is a building of my school. So there is three different objects. For these three objects, we use 300 images. Yeah, for each category, means for each model. And the manual work is data handling is to mark out the bounding box for each object and give their categories. And then use this data to generate XML file, to be trained. And our training environment is the platform is MXNet. It's a very popular platform, and the processor is a GPU because GPU is needed to train the data. And the operating system is Linux, and the language is Python. So all these are quite new technology if you want to do this deep learning related research. So that's the building of SRES, means the School of Resource and Environmental Science. That's my school, the building. So model training lasted for 12 hours with 224 times of iteration to reach convergence. And the MAP could be reached 58.2%. And every image cost 0.03 seconds. So that's actually quite fast. And then the model can be packed into .so file format library for mobile usage. That means with this .so file or library, you can use this training result in mobile phone environments. Okay, then to test this training result, we designed this prototype system. So that's the general framework of the system. But in this system, actually, we use a lot of small technology, which is related to deep learning and also traditional GIS technology. And then this is an image processing model. The picture was taken by a camera of a mobile phone, and then it is transferred to RGB color model, and then it is be input into the SSD. That means the computational computing and extracting the feature layer and the linear regression of a bounding box, and then use softmax to classify it. And then we use this three-dimensional image registration algorithm. That means you must put this recognize the outer bounding box of the object onto the video or onto the image itself, to make this kind of combination. So here we use image registration algorithm. And then we design a series of labels to display all these identified object and its attributes information, including these labels on the right. And this is the interface which you can see later on the real demonstration. So we have this surface view, and we can see the object itself, and we can see the bounding box of the object recognized, and we can see all these labels, which is adhered to, and we can see other kind of information if you want. And that's how to implement this system. We use this development environment, like we use Android version 4.4.2, and the SDK is 25, JDK is Java 7, and the tool is Android Studio 2.2.3, and we use language Java and we use the database SQLite, which is on mobile phone, basically. And that's the result, the taxing statistics. Yeah, we have this picture on different time of a day, and for each category of object, and its average confidence value, and its average time needs to recognize it. Is how long to recognize one object. Yeah. Okay, that's the result. That means the computer itself can recognize this object with a bounding box, which is recognized by computer themselves, based on this SSD deep learning system. When we train them, however the camera sees the object, they can recognize it in a very short time, actually. Yeah. So, if the computer itself can recognize this object from the video, from the camera, then that means your phone can recognize this object, anytime or anywhere, anyhow. So this are actually very important to teach computer to recognize something and to visualize all the information about this object to the user. So then I have a short video. I don't know if it is working. Oh. So this video is made by my students, and that is also a very good opportunity for you to see my campus. So that's a building which is belong to some other faculty. It's basically from my building. And you see the object itself, and you see the framework, the bounding box, and you see all this information adhered to this object, and the location, and the description, and the okay, that's no, it is not on the activity. Okay, I don't know why. I can see video here, but it's not there. Sorry. I can do it. It's okay. So our campus is a very noisy campus because there is a main street right from the square, and there is a building. That's the statue, and behind is the main building of the campus. That's just one part of my university. the computer recognizes the building itself. Okay, so we will go to the conclusion, what we have achieved. So one is we introduce spatial information into this hybrid image tracking and registration technology. So this image tracking and registration comes from computer science. What we think is how to use this technology for GIS application. And then we use deep learning technology for outdoor augmented reality. That is an innovative approach to combine deep learning and augmented reality together. And actually it is practical. And then we developed a geo-augmented reality on mobile phone so that you can use mobile phone to use this augmented reality system. Of course, if you use this HMD head-mounted display, you can also use this glass or HMD to see the augmented information in your site. And our future work will be, again, we need to optimize the structure of CNN. That's the task forever, yeah. And then tracking accuracy improvement, and also we need to enriching the augmented information on the screen. Yeah. Okay, so that's all for my presentation. Thank you.